Hi there everyone, welcome to the video lecture series on set theory. In this video lecture, let us continue our discussion on writing proofs of some important statements in set theory. One of the statement over here I am taking is the following theorem: A union B intersection C is equal to A union B intersection A union C. Now, recall that this is one of the laws in set theory that we had seen in our previous video lecture. This is the left-hand distributivity law, the name that I had given to this. Okay. Now, also recall one of the crucial definitions of equality of two sets under set theory that we had discussed in our previous video lecture, that we say that two sets are equal if and only if the LHS is subset of RHS and RHS is subset of LHS. That's what the implied meaning in the definition was. So in order to prove this equality over here, we shall go by the definition and prove that the LHS over here, A union B intersection C, is subset of A union B intersection A union C. Okay, and we shall prove that A union B intersection A union C is subset of A union B intersection C. Now, I would like all of you to think for a moment that whenever you have any mathematical statement in front of you, like this one in set theory, always think about its definition carefully. That, see here, though you see that A, B and C are three sets in front of you, it's not about three sets, it's about LHS considered as entirely one set, okay, and RHS is considered as one set. This is one important point. Okay, it's talking about the operations operated on the sets, and this is the kind of output that comes in the process. But on their entirety, you try to see that LHS is one set and RHS is another set. Now, this is the kind of mathematical refinement of thought that is needed while proving any statement. Okay, so those of you are in mathematical undergraduate course or postgraduate course, they are familiar with this kind of pattern of proving the mathematical reasoning, with the mathematical reasoning that we go and the logic that is required. For those who are new, the following proof will give you the training and the understanding of how to write the proofs in mathematics. Okay, so that's my effort over here, so I'll try to help you out with that. So let us write the proof over here. So we'll take up the first part, that is LHS is subset of RHS. So A union B intersection C is subset of A union B intersection A union C. That is what we're gonna prove. So let X belong to A union B intersection C. When it is belonging to A union B intersection C, what is the meaning of A union B intersection C when an element belongs to that set? It means that either X is in A or X is in B intersection C. Either one of the two set this element belongs. Suppose X is belonging to set A. Suppose that X is belonging to set A. Okay, so what it happens that if X is belonging to set A, then one very important result over here, I would like to put a star over here, then X is belonging to A union B. This is the place where the spark in the thought is required. That's why I'm putting a star. Now, how do you get a new set into the picture? It's due to the property of the union. Let us think carefully. See, X is already an element in set A. That means X is an arbitrary element. It can be anything. Okay, doesn't matter. Okay, so being an element of the set A, what can I do that it doesn't loses the set A? I can obviously take the union of A with any other set. If I take A is being done the union with the set B, then the element X won't go away, because with the union the property that X remains in the set will be preserved. So X is in the union A union B, right? It's in the union over here. So this is very crucial. So whenever you do the union of set A with any other set, that element X will always remain in that union. This is very crucial understanding of mathematical set theory. Okay, now since I did union arbitrary, it's the B came because I needed the set B into the picture. I have done union with B. Now I also need the set C, so I will do union with set C. Okay, also X belongs to A union C. Okay, remember, instead of, now you had many sets, suppose you can do any number of unions that you need, but right now you need B and C in the picture, so right now you stick to B and C. But understand this as a crucial fact, that when I do the union, the element does not vanishes. Okay, because if I do intersection of A and B, it may not be there, because then I will have to put restrictions. But when I do union, it always remains there. Okay, so X is in A union B as well as X is in A union C. Now remember, A union B is a different set and A union C is another different set. These are two different sets. What I am now saying, that X is in A union B as well as in X is in A union C. That means, from the logical understanding of mathematics, here you will have a claim that X is in both of them. So it means it is in the intersection of the two sets. How? Say A union B, if I call this as some capital set X, and if I call A union C as a capital set Y. Okay, I am saying X is in the capital X as well as X is in capital Y. That means what? It's an intersection, right? So when it is in the intersection, it is going to be in the both the sets. So just what I am going to have here, that X belongs to their intersection. So since X is belonging to their intersection, X is belonging to A union B intersection A union C. The struggle of getting X into the RHS is over. Remember, we started that X is an element in A union B intersection C. We landed up with X in A union B intersection A union C. Right? Hence, we say that A union B intersection C is subset of A union B intersection A union C. This is the first part, and the crucial part of mathematical set theory or the logic was here. Okay, at the star step. Okay, let me take you to the part 2. In part 2, we show that A union B intersection A union C is subset of A union B intersection C. So again, let X belong to A union B intersection A union C. Now since it is in the intersection, it means that X is belonging to A union B and X is belonging to A union C, right? Now try to simplify this statement further. X is belonging to A union B. What does it mean? It means that X belongs to A or X belongs to B. There is a logical connective over here, and so keep it untouched. And X belongs to A or X belongs to C. What does this entire statement means? X belongs to A, right? Or X belongs to B and X belongs to C. That is the meaning, right? We are saying x is in A or it is in B, x is in A or x is in C. So that means x is in A or x is in B and x is in C, right? So that is the meaning of the logical uh, connectives that we are using, logical connectives that we go through. So x is in A, either x is in B and x is in C. So either becomes, or you can use or also. So what does this give you here? That x is belonging to a union B intersection C. This is the the play with the logical connectives of mathematical logic and how set theory is connected here. So this is how it is here. So you started with x belonging to a union B intersection A union C, and you landed up with x in A union B intersection C. So that means you have achieved the claim that what we wanted. Now from 1 and 2 we see that LHS is subset of RHS and RHS is subset of LHS, hence we can claim our statement. Okay, now I request all of you to go through the entire proof, because it's very non-trivial if you are not having a background of mathematical reasoning or mathematical proof writing. So this is one of the proofs that I have given you here for understanding and building up the writing skill in mathematics with the help of the mathematical logic and the arguments in set theories that we use. So if you like this video, please hit like button and subscribe to my channel for more content. I'll soon come up with different statements and different videos in set theory and other topics. Okay, so till then, keep solving good amount of mathematics. Thank you.